Here we are in edition 4 of rebuilding the structure on the ICND1 Review Lab, and we have come pretty far. We've gone through, put a base configuration on every single one of these devices, assigned the IP addresses here. We configured on the last nugget OSPF between them all, got our switches configured with a VLAN interface, default gateway. Everything is pingable, everything is telnetted. We configured a default route on router 1, redistribute. Well, I didn't, so I won't want to say redistribute, although you can redistribute. We use the default information originate to propagate that default route to router 2 and router 3, so they can actually get out, although we don't have NAT configured as of yet, so the ISP does not know about them. And that brings us to where we are in the lab, which is, let's dive in here, VLANs. So in I've modified the lab since the last one. So this is probably what you see when you download the lab right now, because it's a work in progress as we evolve. So basic OSPF routing we've configured. I said ensure you don't run OSPF on the router 1 interface connected to the ISP. I don't want to run it here. We safely used a network command that was just for that interface, so we skirted that. Hard code a unique OSPF router ID. Oh, you know what? And actually, when I wrote that, it brought to my mind. I was like, I don't think I did that for router 3. Actually, let's check it out. Let's bring up GNS3. Let's look at router 2 and do show IP OSPF neighbors. I totally didn't. Man, I busted myself. So I left router 3 at the default, which let's bring router 3 into the picture. And we'll put router 2 right there, bring router 3 over here. And actually, this I started getting there in the last nugget, and I must have got distracted. Actually, I don't know if you know this, but my son, my 2-year-old son, he actually I've moved my recording into another room in my house because I was so distractible where I was. So anyway, I'm sitting in a room recording, and my son, I have this window out to my back yard, and it comes up with a plastic baseball bat and starts banging on the wall. And it's funny, I listened to the last recording. I was like, there it is. So if you listen, Cisco knowledge is secondary. If you listen to the entire last night, you'll hear someone that just bang, bang, bang of my son banging on my window with a baseball bat. But I still recorded on just to show you my focus on Cisco. And then well, there were dire consequences for him after I stopped recording. Anyway, that's probably why I was distracted and forgot to do this, but it brings in a great illustration because I want to show you what happens if you set the router ID after neighbor relationships have formed. Check this out. Watch this message. Bing. Reload, like kill your router completely, reboot, or use the clear IP OSPF process command for this to take effect. Once a router picks its router ID, it will be that way until you reboot or reset the OSPF process on the device. That's why it's huge to make sure you set it from the beginning before it ever forms the first neighbor relationship. Let's exit out here. I'll show you how this rolls. Now, it's going to look pretty fast. Watch. I'll hit yes. It's like bam. Okay, you see that? It's down and then it's up. Now, in a real network, it doesn't quite go that fast. It's not too big of an outage, but it will definitely interrupt some voice over IP calls. I mean, you essentially flush your whole routing table when you do that, right? And then allow it to rebuild. So if you have any decent sized network, that's going to take a little time. So, okay, so now if I go back here, I hit the up arrow and do my show IP OSPF neighbor, I keep myself honest to the lab that I just created, and there's 3.3.3. Okay, so the rest of them, I said make sure this encompasses the passive interface command that we use, and then disabling routing on the switches and set them to a default gateway. So essentially the stuff that we discovered, and I know, we went through and set the default route, and I know as we now get into VLANs, that's the topic of this portion of the review lab. We're also going to run into things where I'm like, oh, and I'm going to add this and that and this and that. That's the fun part about all this. Okay, so wait a sec. We're right here. So where are we now? Add the following VLANs to switch 1, 2, and 3. Also, ensure these VLANs are allowed to pass through between all switches. That doesn't sound quite right, but I'll fix that. Allowed to pass between all switches. You can optionally use VTP to save some configuration time. So let me translate that into English. So we've got the VLAN 2 is IT and VLAN 5 is accounting. We saw that on the network diagram. So what it's saying is add those VLANs, these guys right here, to switch 1, 2, and 3. Add them, and you can use VTP to save some time. You remember VLAN trunking protocol allows you to create the VLAN once and it replicates to all the switches, I'm cool with that. Now, I know some people have had it wipe out their entire network, and if that happened to me, I would not be cool with that. But usually, as long as you're careful with VTP, it's not a bad protocol. That being said, I want to make sure you know that Cisco does not recommend that you use VTP because you can blow up your network with it. If you accidentally delete a VLAN, bam, it's gone from every switch in the network. It's not good. So, okay, so let's run the risk and do that. One other thing, I had this thought as soon as I saw it. I want to add to the LAN is hard code the trunks, right? I'm going to hard code the trunks between the switches. I don't like any of this auto negotiation of trunks between the switches, just like auto negotiation of speed and duplex. Not a good thing. So let's bring them up. So let's get switch 1, switch 2, switch 3, get our players in the network. Is that all of them? Switch 1. Switch 1 did not make it. There we go. So let's go on to switch 1. I've got the ports right there on the diagram. Actually, let's get back to the diagram. Right there, but I'm going to do a show CDP neighbors just to see, and I can see I've got switch 2 and switch 3. I see them on those ports, so let's go in and let's hard code those trunk ports at the same time. So I'm going to do interface. Let's go interface range fast Ethernet 1/1 through 2. We'll do switch port trunk encapsulation. Some devices make you type this, others don't, but it's usually good at least to check it out, make sure it's there. And then switch port mode, and you can remember we have access or trunk are the two different modes. Actually, in switch port. Hang on, what am I thinking? Switch port. Yeah, okay. So on real switches, I was like, wait a sec, that's not all of the modes. There is actually the dynamic, there's the DTP. Later on in the series, I'll actually use a pair of 3550s, real switches, not in GNS3 to show you. There's dynamic, desirable, there's auto, there's other modes, but here we actually have to go in and hard code trunk on those, or access. And you can see that as soon as they do that, these guys are like, whoa, something has changed. So I'll do a show CDP neighbors here on switch 2. Let's go into interface fast Ethernet 1/0, switch port trunk encapsulation.1q, and switch port mode trunk, and do that. It's funny, as I'm doing this, I remember I was actually, where was I? Show CDP neighbors somewhere. I was talking to a gal at it was at some site I was working on, and I was doing exactly this, configuring trunk ports, and I was just like, interface, fast Ethernet 1/0, switch port trunk, and I was doing exactly this, and she goes, "You're amazing! How do you do that so fast?" And I turned and looked at her. I was like, 13 years. I was like, that's enough said. If you do the same thing for 13 years, it tends to stick with you. So I say that not to be like, look at me. I'm like, good grief, I should probably be 10 times faster because I have been doing it for 13 years. So it'll just kind of come to you. Okay, so we've got the trunk port. So let's do a show. Let's go back to switch 1, just because he's kind of the core of it all. Notice I love these status messages. Yum. Port fast Ethernet 1/2 has become a .1q trunk. I don't know why I said show interface trunk. I don't want to say yum there, but I can't type. Show interface trunk. So you're able to come in here and see the trunks that are there. Now one of the things that the lab said, that I got to reword this because it doesn't quite sound good. It says ensure these VLANs are allowed to pass through between, or just pass between all switches. That means that the trunk port should allow all these VLANs through. Now we haven't created any VLANs yet. And I want to use VTP to replicate them, like I said. So the VLANs are going to be 2 and 5. And since we are using GNS3, we kind of have to use the old school way of doing it. So if I go into global config mode, you'll see VLAN is just stripped down. There's nothing really there. Same if I type VTP, it's like, I don't exist. So if I drop back out here, the old school mode of configuring VLANs, this is how you used to do it 13 years ago on Cisco switches. Actually, not that long, maybe 5 years ago. Is when they really made the jump to everything global config. But notice I'm in privilege exec. I'm going to type in VLAN database. So it takes you into this little VLAN database mode, and everything that you do in here just kind of it goes in limbo until you exit out. And when you exit, that's when it applies your changes. So it's kind of like you're in this limbo mode. Whereas in the new switches, as you do things in global config mode, it applies it right then. It's in effect. So. So first thing I'm going to do is I'm going to say I want to create VLAN. The commands are virtually the same. So I'm going to say VLAN 2, and I'll type in name, and we'll call this the IT team VLAN. And we'll say VLAN 5. Now it says VLAN 2 added name IT team, but it actually didn't until you exit. So I'll say name accounting. Right, so I've created those VLANs. Now again, no ports have been assigned to those VLANs, so they're just kind of there. They're just hanging out there on the switch. But I said I also wanted to use VTP. So let's can I do that from here? VTP. Yeah, there we go. VTP. So we are a server. So I'll type in VLAN. It's like, hey, you already are a server. So I'll say VTP domain. So I'll say that the domain is going to be CBT nuggets. And it is case sensitive, so when I set the domain on all the other ones, unless they replicate, and I'm not too sure on GNS3 if it's going to, I'll say if it's a real switch, it will, if all the, if all these guys, let me do a show VTP status, if all these guys are set to a, oh, holy cow, look at that! Do you see that? It just adopted CBT nuggets. So okay, that's really interesting to me because so VTP. I learned something new just then. VTP, or not that it's relevant for today, but VLAN database mode. The VLAN changes don't take effect right away because if I come over here and do a show VLAN. VLAN switch on GNS3. I don't see the new VLANs I've created, but what did take effect right away is VTP, because as soon as I change it to CBT nuggets, I bet you now, if I go down here, do a show VTP status on switch 2, yeah, check it out. They all adopted, they all became CBT nuggets as their domain name. So that's really interesting. I did not know VTP or VLAN database mode did that. Okay, so now when I exit, hold our breath. Boom, apply completed. I'm going to do a show VLAN switch. And now I see VLAN 2 and VLAN 5, IT team and accounting, and if VTP did its job, let's do a show VTP status here, and you can see that we are at configuration revision number 1. So it's added made the changes to VLAN database, incremented the revision number. So now, if I hit the up arrow right here, I bet you this guy, yeah, look at that. Configuration revision number 1, show VLAN switch. So what do you guess? There they are. IT team and accounting has also been added to both of these switches. Just VTP has done its magic. Now, if you're like an anti-VTP person, you can use VTP to do this, to make these changes, and then turn it off. You can flip the switch to transparent mode now that you've done your initial replication, and at least save yourself a little work. There, obviously, you'd want to do that for more than 2 VLANs. Otherwise, what's the point? But you get the point. Okay, so. Now, I'd like to add to this switch, or add to this lab, and I know you guys are probably going to read this lab before you get to here, so you're seeing me do a different version, and kind of create it on the fly, but the lab objectives will eventually reflect this. So I'm going to go into switch 1. I want to restrict the trunk. So when I said in the lab, to ensure these VLANs are allowed to pass between all switches, I want to say only these VLANs. So only the VLANs that we're using in this environment are allowed to pass between the switches, which are going to be VLAN 2, 5, and, of course, don't forget VLAN 1. So I'm going to go into switch 1 and do interface, well, actually, what was that? Interface range, fast Ethernet 1 and 2, because that connects to both the switches. And I'm going to type in switch port trunk allowed VLAN, and we'll say 1, 2, 5. Enter. Bad VLAN. You have to include all default VLANs. And some older switches will say, but you have to also add in 1002 through 1005, because you see these guys, these are like the standard from yesteryear. Remember Token Ring? Yeah, they have a VLAN for that. So they're like, oh, you got to include those guys too, and that's cool. I'm good with that. So such a crazy, like, I'm going to tell you something right now, and I guarantee you 20% of you will make this mistake in your career because it's so common to do this. So let's say down the road, your company adds VLAN, we'll just say 3, which is a voice over IP VLAN, right? So they add VLAN 3. So you're like, oh man, I got to go back and I got to update all of the trunk ports to allow that. And you come in here, and this is like a made-for-TV movie where it's going to go in slow motion. It'll be allowed VLAN, and it's like, no, and you type 3 and hit the enter key because you're like, I've got to add that one to the trunk. But you know what it does? It replaces this entire list right here with VLAN 3. So essentially then it becomes the only, you see what I mean? The only allowed VLAN is VLAN 3. So in the future, if you ever have to add any VLAN, that's why they have the add keyword. So add VLAN 3 instead of just typing in allowed VLAN 3, which wipes everything out except for VLAN 3. So anyway, I'm telling you that now, and it's funny when I teach in a classroom environment, I always ask in some of the advanced classes, I'm like, how many of you have done it? I guarantee you, at least 4 or 5 hands out of 10 people will go up. It's a common mistake to make, and it causes a complete network outage. So it is one of those ones where you're like, no, cold sweat and all that kind of thing. So what was I talking about? Allowing the VLANs. Let's go over to switch 2. And switch 3. So I'm going to go into switch 2, which I'm going to go into interface fast Ethernet 1/0. Actually, I'll just hit the right click key, which I used to have with the right VLANs in there. So I'll just copy this, right click it in there, bang, that one is allowed. So we can verify, and let me do this one because it takes a sec to go into effect. Show interface trunk, and we should see, VLANs allowed, the VLANs that are actually working in the management domain are the ones that we specified right here. We throttle it down to just so. So last switch 3, I'll go into global config mode, interface fast Ethernet 1/0, and then, did I do it again? Just these guys. Paste. There we go. Okay, so now we've got the VLANs created and assigned to the trunk. So now it's working. We've got the VLANs there, but they're not actually doing anything. Now let's just read ahead a little bit. It says configure router 1 to perform routing for VLANs 2 and 5. Okay, so we're talking router on a stick here, where router 1, it says for each subinterface, router 1 should use the first valid IP address from each VLAN. So router 1's going to pull the router on a stick, the router on a stick configuration here, to where it's got a sub-interface for VLAN 2 and VLAN 5. This is what we did in ICND 1, so that now these guys, which are going to be assigned to the VLANs, will actually be able to go through that router and communicate with each other. But that's coming up. So let's look at the next couple steps. It says, okay, configure router 1 as a DHCP server. This is awesome. So we're setting up this whole little network here for VLAN 2 and 5. The DHCP server should distribute client IP addresses between 100 and 150. Okay, bing, that should stick in our head. And a DNS server of 4222 with a secondary of 888 and the appropriate default gateway. Okay, so we're configuring router 1 as a DHCP server. That's awesome. And then finally, this will eat up the rest of the nugget right here. Assign PC A to the IT VLAN and PC B to the accounting VLAN. Verify that they receive an IP address via DHCP, and then verify routing by pinging from PC A to PC B. So this guy is in the IT VLAN, this is in the accounting VLAN, and we're going to route between them. This will be good. All right, so what was the first thing? Router 1, router on a stick, right? So we'll go into router 1. I haven't even accessed router 1 yet, so let's bring him up. Bring him online. The way this is going to, this is a good one. We've got to configure fast Ethernet 1/0 as a trunk as well, right? Because it's going to be feeding those VLANs to router 1. So don't forget that. Remind me before we get done, or else I'll forget. So I'm going to go into interface fast Ethernet 0/0 dot. I'm throwing the dot on there. Now, you don't have to match the subinterface number to the VLAN number, but good grief, why would you not? So I'll type in .2, which creates this subinterface. Before you can assign an IP address, you have to use the encapsulation .1q to assign what VLAN this belongs to. Now, this is what tells it what VLAN it works for. Now I can type in the IP address. Why did it do that? Oh, okay, because it's just kind of renegotiating that interface. So IP address is, what was IT? 10.24.2.1, right? Is the IT VLAN. Okay. So exit out of there. Let's hit the up arrow a couple times, and we'll go fast Ethernet 0/5. That's our accounting group. It'd be good to put a good description on these interfaces. Accounting VLAN. So that way, when we look later on, we can be like, oh yeah, that's why that one's here. So we'll say IT team VLAN. So let's go back over here, and we'll do encapsulation .1q VLAN 5 IP address 10.24.5.1 25525. That was the first valid IP address. Good, right? So we've now got this router on a stick, which now we're bringing up all these little sub interfaces, but they're not going to work because you reminded me, thank you, that I need to go on switch 1, bing, and I need to go and configure interface fast Ethernet 1/0, this one connected here to the router 1 interface, as a trunk. So I'm going to go in here and do switchport trunk encapsulation .1q period. Switchport mode, not service policy. 13 years, can't even type it. Switchport mode mode trunk. Jeremy, just type the commands. Switch port trunk encapsulation. No, wait. What am I? Switch port trunk allowed VLAN. Got to get my brain back on track here. 1, 2, 5, and what was it? 1001 through 1000? No, it was 1002. What? 2? Anyway, it took it, so we're good. So let's do a show interface trunk. Make sure that we're in action there. Good. So you see, I said it takes a minute to add them in here. But this will now allow the VLAN. So it's saying these are allowed and active. We're just waiting for them to actually. There we go. Now they're added in the forwarding state to router 1. Good. So drop back here. Router 1 is performing router. Now let's configure it as a DHCP server. So I wonder, this would probably be better to do in Notepad, because if we do it live on the router, we can just copy and paste it. Let's do it live on the router. We live on the edge. By the way, in production, very rarely will I type anything into a router live like this. I usually type it in Notepad, look at it, have a friend look at it, test it on some equipment, and then type it in. If I'm in a severe production environment, I mean mission critical, I should say. But this isn't mission critical. So we'll do, so in DHCP, unfortunately, Cisco doesn't allow you to assign a range. I'm on the wrong device anyway. They don't allow you to assign a range of IP addresses. You can just say what it isn't allowed to hand out. So we first have to go in, and I'll be saying, what is it? IP DHCP excluded address is the command, to say, okay, I don't want to hand out 10.24.2.0 through 10.24.2.99. Remember, the lab said that we want to hand out 100 through 150, right? That was our magical range right there. So I actually, instead of saying 100, 150, I have to exclude everything around it. So I want to hit the up arrow and say, I also want to exclude 151 through 255 on that. And you see, this is where you'll be like, oh, that's why you wanted to use Notepad. So I also want to do 5.0 to 5.99, which is the accounting VLAN, and we'll do the same thing here, 5.255 and 5.151. So we're saying what we're not going to be handing out from those ranges. Now, I want to go in and configure the scopes of what we are going to hand out. So I'll do IP DHCP pool, by the way, on an ASA. That's why my fingers naturally did that. They call it DHCP-D on a Cisco firewall ASA, DHCP daemon. Here we use IP DHCP. So IP DHCP pool, we'll just call this, how about something creative like IT team? Got to remember that case. So I'm going to do IT team DHCP pool. First command, actually, let me hit the question mark. There's all the commands we can do, lots of them. And I'm going to do network. That'll be the first one. So the network I'm going to hand out is 10.24.2.0. One of the few commands that actually allows us to put a /24. That's awesome. DNS server, I remember that, was 4222 with a secondary of 8888. Throw that in there. And default router, default gateway is what they wanted of 10.24.2.1, which will point it to our router on a stick, right? That's the IP address that we assigned to router 1. So anybody getting the address via DHCP will get all the correct saying. Was that all of them? So we've got the DHCP server, addresses, DNS, and default gateway. Yeah. So now this is where that Notepad would have come in handy. But I can actually exit out here, do a do show run section DHCP, and just grab this guy out. This is one of those ones where you go, was it really faster to paste it in there? IT team. So we'll say accounting, right? And this is where we'll just go in and change them to 5. So we'll say 5. So I don't know. What do you think? Was it faster? Maybe. So come over here, paste it in, counting, good. So now both the DHCP scopes are good. We're humming along. Let me, oh no, my Notepad froze. I can't move it anymore. I've never seen Notepad. Oh, there it goes. It's gone. I'm happy. So, I've never seen Notepad freeze before. Okay, big culmination of all the VLANs. Assign PC A to the IT VLAN and PC B to the accounting VLAN. And then let's make sure they get an IP address and then make sure that we can ping between them. So I'm going to go to switch 2, first of all, which is the one connected to PC A. So let's do a show CDP neighbors, and not that I don't trust my diagram, but PCA, which really is a Cisco device, is connected to Fast Ethernet 1/1, so it looks good. So I'm going to go into Fast Ethernet 1/1, and we'll do switch port switch port. Actually, let's do switch port mode access. I bet you that's the default on these Ether switch modules, but it just makes me feel better to hard code it like you're not a trunk. Switch port mode access, and I'll do switch port access VLAN, and this is going to be in the IT VLAN, so that's VLAN 2, right? So let's bring up PCA, which is our little Cisco device as well, just to see where it's at. So it's got DHCP, but it only sends DHCP requests every so often. So let's go into interface fast Ethernet 0/0, and let's do a little shut, no shut, to kind of make it like it'll bring it back up, and that way it'll be like, okay, I'm ready, and it'll send a DHCP request, and we'll see if it comes up. DHCP. So while we're waiting for that one, let's go over to switch 3. Something that takes a little bit. Or we may have broken something, which will be great for troubleshooting. So we'll come to switch 3 and show CDP neighbors. We've got, there's our switch, okay, switch PC1. Okay, that's good. PCB, I should say. So, oh, you see that behind the scenes? That's good. So I'll go into fast Ethernet 1/1, do switch port mode access. Switch port access VLAN. Now you are VLAN 5. You are an accounting VLAN. And let's check this. Notice it said I got an IP address 10.24.2.100. Is that verified? It is. That is the IT team VLAN. So it is grabbing one from the right VLAN. So we'll say switch port access VLAN 5 for that guy. Let's bring up PCB. Oh, I bet you I double clicked on the B. Yeah, GNS3 doesn't like that. So PCB, let's go into privilege mode, show IP interface brief. It also is configured for DHCP, so let's just accelerate things. Fast unit 0/0. We'll do a shut and a no shut. I don't know why I wait for the status message. I don't think you have to. I just always have before I actually execute that no shut. So it's up. So we'll give that a moment. Wow, that was fast. A lot faster than the other one anyway. So check that out. So it grabbed an IP address. Look at that. 5. Bing. Accounting VLAN. Golden. So we go to router 1. Show IP DHCP binding. Such a great command to be able to say what's going on here. And we can see that we've got 2.100 being handed out to this. It's like, what on earth? That is good old GNS3 in action. They're not real MAC addresses, but man, that is a nice big MAC address. And then we've got 10.225.5.100. Normally it would just show the MAC address of the device that's leasing it. I can verify they're being handed out, and by golly, they're going to expire a good 11 years ago. So we got to set the clocks at some point on our devices. But that added to the VLAN. So let's just recap. Before I want to make sure we've done everything VLAN wise. So I don't think of something else I want to add. We've got the VLANs configured, VLAN 2, VLAN 5. They're passing. Actually, we limited the trunks. So I'm going to add that. Limited the trunks to only allow those VLANs. We used VTP. You don't have to. You can manually go and create VLAN 2 and 5 on all the switches. Actually, since there's only 2 VLANs, it's not that much more work. Configure router 1 to perform routing for VLAN 2 and 5. We did that. Each subinterface used the first valid address. And we configured DHCP and assign the individual PCs. Oh! we never actually tested it. I'm glad I did this. So let's test it. Matter of fact, I'm going one beyond. I'm not just pinging, I'm trace routing. I'm going to do a trace route to 10.24. So I'm going from PCA, so he's in the IT VLAN, to 5.100. So that's the IP address of PCB in the accounting VLAN. I hit the enter key. Oh man, I got to turn that off. What you're seeing right there is an example of IP domain lookup in action. What it's trying to do is look up the IP address to each one of those. So while we're waiting for that timeout, I'm going to fix it on PCB. You go in and no IP domain. I know we did this in the base config, but we didn't do it to the PCs, and I'm doing that right now. I broke out of there. So no IP domain lookup. So now we can go back and try it again. Trace route to 5.100. Oh, that's good. Well, it was good. Oh, there we go. So it's getting there. It's just dropping a couple pings. So it's going through its default gateway and connecting to this device. So this always happens to where you will hit this and then and there's a whole write-up on why Cisco does this. I just can't remember. It always drops the second ping attempt for a trace route on the last leg of the thing. And there's actually a big, good technical reason why. And I read it and I was like, that's interesting, but that's where I left it. So we'll do it traceroute back 10.24.2.100, making sure that we are getting there back. PCB says, hello PCA, and I'm going through my router on a stick to get there. Awesome. VLANs are good. I hope this has been informative for you, and I'd like to thank you for viewing.